So let's start with rotation of objects. So we're looking at rigid objects only. Now, why do we need such discussion? So when we have a wheel rotating, so a wheel rotates about its axis, right? A wheel, it rotates about one particular axis. The motion cannot be analyzed by treating the object as a particle, because at any given time, different parts of the object have different linear velocity and linear acceleration. We have seen this in last chapter, I guess. So if I have an object, or I can go to the video itself. So each of this part, or let me go to this itself. So when I do rotate it, so each of this part will have different acceleration, different velocity, different amount of distance that they have traveled, right? So it would be so when they do rotate. Okay, is that true? Each part has their own values and stuff like that. So it's not practical for us to continue using the same discussion. So we need to think to have, we need something that is common to all. We need things that is common to all to help. It's helpful for numericals and discussion. That all particles are at same angular speed but different linear speed. So that's the one which will help us. So to define rotational motion, a body is said to be rotating if all its particles move along along circles in parallel plane. So here the key word is parallel planes that you need to keep in mind. That is one word that people miss. So let's not do that. Okay, so there are a few technical words that we need to relate with rotational motion. So it starts with reference line, reference frame, axis of rotation. Let me go to this. So reference line has to do with, say, a line. So as and when the object rotates, it also rotates. Okay, so that's your reference line. Now, reference frame or inertial frame, it's fixed in space. So even when the object rotates, this will not rotate. So say something like this. So this is fixed. And these are reference lines, and it was over here at, say, t is equal to 0, and this is t is equal to, say, after 2 seconds. So that has moved. Then we need to talk about axis of rotation. So that line wherein things will not move. So this we are considering to be fixed. So around this things are rotating. So that's how we can think. Along this line, things will not per se rotate. So this is your axis. So, okay. Now let's look at the definitions per se. Of reference line is fixed in a body. Okay. So as and when the body moves, that also moves. It is perpendicular to this axis, and it rotates with the body. So let's look at the definition. Reference line is fixed in the body. It's perpendicular to the rotation axis and rotates with the body. Next is reference frame or inertial frame. It's fixed in space, stationary relative to the ground or lab, serves as our measuring stick for quantifying the motion. So with this, I'll be able to tell that, it turned 30 degree over here. It turned around 74 degree over here. So this is where we can start and discuss. So that can be your reference point. This is the starting point basically. Right? And next set of terms are sweeps out an angle of theta, or angular displacement, angle through which an object rotated. An angular displacement in the counter clockwise direction is positive, and one in the clockwise direction is negative. So the direction of angle also has to be known. Okay, I'll teach now itself. So if I happen to see something rotating in front of me in anti-clockwise direction, then the direction of the angle per se, or angular displacement actually. So the angular displacement is positive in this case. So in this case, the angular displacement is positive because the object is going counterclockwise direction. From my point of view, it is counterclockwise direction, right? If it's clockwise direction, if it goes the other way around, I'll tell the angular displacement is negative. Then we have our traditional names, that is your angular velocity, how fast the angle is changing, and angular acceleration. The new word over here is, other set of new words, is momentum of inertia and torque. Moment of inertia is equivalent to mass. That is how difficult it is for me to rotate something. And torque is the one which causes the rotation. Again, I repeat, moment of inertia is like talking, if the moment of inertia is high, then it is difficult for me to rotate it. If the moment of inertia is low, means it is easier for me to rotate. Torque is the one which causes the rotation. Okay, guys. So we have moment of inertia. Okay. So it's generally represented with I. So this more the value, difficult it gets for rotating it. More difficult it is for us to rotate. More difficult it would be for us to rotate. Okay. And vice versa. So the opposite is also true. Now, next is torque. Torque is the one which causes the rotation. That's all I'll go with. We'll go to the details later, because once you look at the formula, it will make more sense. So I don't want to explain more over here. We have a separate video for that. Now, are all of this quantity is vector? Angular velocity, acceleration, torque are vectors, while angular displacement is not. So the reason being, angular displacement does not obey the rule of vector addition. So again, we have to see this in detail. For now, it's just an overview of rotational motion. So rotational motion, we need all of these terms for analyzing an object under rotation, because each part will have its own linear velocity, linear acceleration. So it's not very convenient. So we need one term or set of terms that will help us discuss commonality in all the object. That is your angular displacement, angular acceleration, and so on and so forth, right? So to discuss any kind of movement as rotation, we need certain reference point, and those are your reference line, reference frame, and axis of rotation. So reference line is fixed in the body, and it's perpendicular to the rotational axis and rotates with the body. Reference frame or initial frame. So as the word inertia, what does it tell? It's fixed in space. It's stationary relative to the ground or lab, serves as your measuring stick for quantifying the motion. Then axis of rotation. Axis of rotation is an imaginary line or point around which a rigid body or system rotates. Next, angular displacement, angle through which an object rotates. And angular displacement is, if it's counterclockwise, it's positive. If it's clockwise, it is negative. And we have angular velocity, how fast an angle is changing. Angular acceleration, how fast or slow change in angular velocity is. Moment of inertia is how difficult it is for me to rotate something. Torque is the one which causes an object to rotate. And yeah, other than angular displacement, we have velocity, angular acceleration, torque to be vector quantities. Okay, so I think you can write all of this. Write all of this. And then you need to draw this.